Okay, hope everybody's doing well. I can't believe this is the last week of actual schoolwork. So we are counting down the days. Feels so good. So yesterday you watched the video with Mr. Larson as he showed you how to do scatter plots, and then also taught you the line of best fit. So today we're gonna just kind of review that also and go over a few things with some story problems on figuring that out. So I'm on page 140. If you would turn to your book to page 140, I'm gonna do page 140 and 141 with you. And then your assignment today will be page 143 and 144, and then the quiz, the daily quiz. Okay, let's go ahead and start by putting up at the top our y-intercept form, which is y equals mx plus b. Okay, and we know that m is slope, and we know b is our y-intercept. Okay, so when hopefully you know that when we have a scatter plot, we're going to actually plot all this data in just a second. But you know, we need to make sure that we find the line of best fit and look for the general trend when we're doing it. Okay, so if we have all the dots here, we're not going to have a line way over here, and if we have all the dots there, we're not going to have a line down here. We want to have it in a general trend area. Okay. So right here it says number 4 says use this table of data shown below to answer the question. So A says create a scatter plot. Now so we need to look at these and start plotting them. 0 and 16, 1 and 15, I like to actually mark them off as I go. 1 and 12, 1 and, let's see, 2 and 13, excuse me, 2 and 13, back up there, 2 and 12, right here, 3 and 11, so 3 and then 11 should be about right here, 3 and 10 is right here, 4 and 8, 4 and 8 is about right here. 4 and 7 is about right here. 5 and 6 is about right here. 5 and 5 is right here. 6 and 4 is right here. 6 and 3 is right here. 7 and 2 is right here, and then 7 and 0. Okay, so now I have created a scatter plot. Sometimes if you feel like you need to put numbers off to the side right here to help you figure out where you are, feel free to do that. Okay, sometimes that helps. That's not 8, that's supposed to be 10. Sometimes that helps, okay? So that you can see where that is if there's some points there. Okay, now what we need to do is we need to look at the general trend, what's going on. Well, first of all, we know that it is going down. So we know that it's going to be a nice negative according to Slope Dude. Because if it was going this way, it would be a puff positive, but we see that our general trend right now, it is going down. So we know that it's going to be a negative, right? So it's going to be a nice negative. So then we take our little fabulous ruler and we are going to try to do a line the best that we can through all our scattered plots here. So I'm going to go about right there as my general trend, okay? As my line of best fit. That's where I want to go with. Okay. Now, it did say right here, so I just did B. B, use the ruler and draw a line of best fit through the data points that captures the general trend of the data. Okay, so there we go. That's what I've got there. Okay, so now it says estimate your slope and your y-intercept on your line. So C is that. So my slope, so I need to find 2 points where I feel like it went through pretty well. So I'm going to use this point and I'm going to use this point. So I'm gonna draw kind of like a magical triangle there to see those points. Well, 10 to 12 is 2, and from 3 to 2 is 1. So my rise is 2 and my run is 1. So rise over run, so -2 over 1. So that is my slope. Now my y-intercept, it's actually a little bit below 16. So I am just going to, I'm going to guesstimate and say about 15.8. Okay. So down here it says estimate the slope and the y-intercept of your line. So -2 over 1, we know that that means just -2, right? Anything over 1 is what the top number is. And then b, which is, remember our b is wherever it goes through the y-intercept. Here's my y. So right there, I said about 15.8 was a little bit below my 16 when I did my line of best fit. Okay, now it says write a prediction function for the data set. So all we do is we take our slope intercept form and we just plug in the information that we have. So y equals -2x, because we're just plugging it in, plus our b is 15.8. So that's all you do for that. Okay, go ahead and turn your page over to 141. And we're going to do this. It says company XYZ makes and sells widgets. The following graph shows the weight of widgets and the number of widgets put on a scale. Okay, so it says use a ruler. Draw the line of best fit through your data points to capture the general trend of this data. So we know now, right, it's going to be a puff positive, okay? And so we're going to take our little fabulous ruler here, and we're going to try to do our best, our line of best fit on this baby here. And because it's kind of, yeah, oh goodness. Sometimes it's hard to get a really good line of best fit, so that's why it's called estimate the best line of fit, right? So I'm gonna go about right there. Okay, so my line of best fit right there. Okay, now it says estimate the slope and the y-intercept of your line. Okay, so this is my y, right? Okay, this is the y. Let's go ahead and first figure out what our slope is. So I am going to take it from this one to 48. So I'm gonna, or maybe I will take, yeah, let's do this. Let's do this one. So 1, 2, 3, 4, 1, 2. Okay, so remember, this is from 8 to 24. So this is 4, so that would be 16. So 8 to 24 is 16. That's our rise over 20 or over 2, 4. So from 2 to 6 is 4. Okay, and then we simplify that down, right? Okay, so then it would be 4 over 1, because 4 goes into 16 and then 4 goes into 4 one time. So we simplified that down to 4 over 1. So remember, this is for each of those. So make sure you count those right. Okay. So our slope is 4. And then our y-intercept, I'm actually gonna put it as a 1, because I was trying to move my line over, but my pen was just too big. So I'm gonna have my y-intercept as 1, okay? Now, so that's what I wanted to have. That was gonna be my y-intercept right there, is 1. Okay, so now it says write a prediction function for the data set. So we go ahead and just plug that into our formula. So we go y equals 4x plus, which is b, is 1, okay? Because remember, our formula is y equals mx plus b, and all I did was put the information that I have back into that. Okay, What does the slope represent in context? So it's saying, what does this even represent? Well, we have the weight and we have the number of widgets. So wouldn't you just say the weight per number of widgets? I would say weight per number of widgets is what I would say for that one. And it says, what does okay, sorry, half of my paper got cut off. Anyway, so E is, what does the y-intercept represent in context? Okay, so this is our y-intercept, and remember, we had it as 1. So the context is, it's the starting number of widgets. So starting number of widgets. So that is what E is. Now, I already wrote this in when I realized that I had cut off half the page. Now it says predict 50 widgets. So what they're saying is if our plot kept going up with our number of widgets, that means the weight's still gonna go up. So they want us to tell us how much 50 would be. So we're just gonna put 50 in for X. So 4 times 50 is 200 plus 1, which is our y-intercept. So adding 200 to 1 gives us 201 pounds. And good luck.